Swayam Prabha. Digital India. Educated India.
Welcome you all again. If you recall, in the last lecture what we did is the convolution of two functions and what is the effect of the Laplace transform on convolution of two functions. Especially if we have two functions f and g, convolution of two functions is f star g, and if I take the Laplace transform of f star g, this is equals Laplace transform of f into Laplace transform of g. And we have seen that how to use this convolution theorem to solve various problems. In this particular lecture, what we are going to do is to find out the solution of some integrals using the concept of Laplace transform. The first one you see, the apply convolution theorem to prove that beta mn is a very well known function which is being taught in the first years of engineering courses, the beta function. Beta mn, which integral is 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, and we evaluated this integral. If I evaluate the integral, the result is gamma m gamma n by gamma m plus n. Now, we want to see how using the Laplace transform we can find the value of beta mn as gamma m gamma n by gamma m plus n, where m is greater than 0 and n is greater than 0. Let us see this. We are assuming a function f t equals 0 to t, we are taking initially x to the power m minus 1 into t minus x whole to the power n minus 1 dx. Already we have told that m and n is greater than 0. So, we are starting with a new function 0 to t x to the power m minus 1 into t minus x whole to the power n minus 1 dx. So, that afterwards if we put t equals 1, we will obtain the beta function, that is beta mn equals 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. So, your f t is, you can write it in the form of 0 to t f 1 x into f 2 t minus x dx, where we can say that f 1 x this is equals t to the power m minus 1 and f 2 x this is nothing but f 2 t we can make f 2 t here t to the power n minus 1. So, I can write it as f 1 star f 2. This we can write down using the convolution 0 to from the theorem of convolution 0 to t f 1 into f 2 t minus x. I can write it as f 1 star f 2. So, now if I take Laplace transform on both sides of the earlier equation, I will obtain Laplace transform of f t equals Laplace transform of f 1 into Laplace transform of f 2. And using convolution theorem, we know that Laplace transform of f 1 convolution f 2 is equals to Laplace transform of f 1 t into Laplace transform of f 2 t. So, using convolution I can write down this thing, that Laplace transform of f 1 convolution f 2 equals Laplace transform of f 1 t into Laplace transform of f 2 t. So, you are writing Laplace transform of f t equals Laplace transform of f 1 t and into Laplace transform of f 2 t, where f 1 and f 2 are given here. So, that this equals Laplace transform of t to the power m minus 1 into Laplace transform of t to the power n minus 1, which are f 1 t and f 2 t respectively. Now, we know the Laplace transform of both the functions, and this is equals to gamma m by s to the power m into gamma n by s to the power n. So that I can write it jointly as gamma m plus n by s to the power m plus n. So, what you are getting Laplace transform of f t, this is equals gamma m into gamma n by s to the power m s to the power n plus 1. So, effectively you are getting this thing gamma m plus n by s to the power m plus n. This value is basically this one, that gamma m plus n by s to the power m plus n. So, Laplace transform of f t, where f t we have assumed 0 to t x to the power m minus 1 into t minus x n minus 1 dx, we are obtaining this thing. So, from here now you can write down your f t equals 0 to t x to the power m minus 1 into t minus x whole to the power n minus 1 dx, and that is nothing but Laplace transform of f t was gamma m plus n by s to the power m plus n. So, that f t will be equals to Laplace inverse of gamma m into gamma n by s to the power m plus n. So, not m plus n, but gamma m into gamma n by s to the power m plus n. So, this gamma m and gamma n you can bring outside, and you can write it Laplace inverse of 1 by s to the power m plus n, whose Laplace inverse is known to us. So, it will be gamma m n divided by gamma m plus n into t to the power m plus n minus 1. So, f t you are getting as gamma n by gamma m plus n into t to the power m plus n minus 1. So, now put t equals 1. If I put t equals here t equals 1, once I am putting t equals 1, then I will obtain beta m n on this equation, that is 0 to 1 x to the power m minus 1 into 1 minus x, t we are replacing by 1, n minus 1 into dx, and this is equals, this t is 1. So, it will be simply gamma m into gamma n by gamma m plus n. So, please see this one, that once I am putting t equals 1 over here, I am obtaining this value, that is gamma m gamma n by gamma m plus n. So, using the convolution theorem, effectively we are trying to find out the solution of an integration, or we are finding the value of an integration. One thing we did, that is beta m n equals gamma m gamma n by gamma m plus n. This we proved using the convolution theorem. So, just you see it, your f t is 0 to t x to the power m minus 1 into t minus x whole to the power n minus 1. So, this we are writing f 1 x into f 2 x, where f 1 t is t to the power m minus 1, f 2 t is t to the power n minus 1, and using a convolution definition, I can write it as f 1 star f 2. Once I am writing f t equals f 1 star f 2, now take Laplace transform on both sides of the given equation. So, that you will obtain Laplace transform of f t equals Laplace transform of f 1 star f 2. So, that using convolution theorem, Laplace transform of f 1 star f 2 you can write down Laplace transform of f 1 t into Laplace transform of f 2 t, and f 1 t is t to the power m minus 1, f 2 t is t to the power n minus 1, and you are writing the Laplace transform of these two functions as gamma m by s to the power m into gamma n by s to the power m. So, this is equals gamma m into gamma n, not gamma m plus n, which I told earlier. This is gamma m into gamma n by s to the power m plus n. So, now start with the problem. Your f t is 0 to t x to the power m minus 1 into t minus x whole to the power n minus 1 dx, and this now you can write down Laplace inverse of this, because Laplace transform of f t just in the earlier one we evaluated as gamma m gamma n by s to the power m plus n. So, that f t will be Laplace inverse of this thing gamma m gamma n by s to the power m plus n. Now, gamma m gamma n I can take it outside. So, that it becomes Laplace inverse of 1 by s to the power m plus n, and the Laplace inverse of 1 by s to the power m plus n is 1 by gamma m plus n into t to the power m plus n minus 1. So, that on this if I put t equals 1, then your beta m n, that is 0 to 1 x to the power m minus 1, 1 minus x whole to the power n minus 1 dx, this will be equals to gamma m gamma n by gamma m plus n, and this completes the proof that beta m n equals gamma m gamma n by gamma m plus n. Let us take another example. So, we want to evaluate, we are taking another example over here, 0 to infinity e power minus x square dx. We want to evaluate this integral. I think sometimes back we did it earlier also, using of course, the Laplace transform. I am assuming with a function, new function, say f t. F t equals, I am assuming 0 to infinity, since I have to find out e power minus x square. So, I am taking a new function, say e power minus t x square dt, which is a function of t then. So, I am assuming a new function f t, which is equals 0 to infinity e power minus t x square into dx. So, that afterwards whenever t will be equals to 1, then we will obtain 0 to infinity e power minus x square dx. Now, let us see what is the Laplace transform of f t. Laplace transform of f t is from definition 0 to infinity e power minus s t into f t dt. From the definition of Laplace transform we can write down. So, that now if you substitute the value of f t, then you will obtain two integrals effectively, 0 to infinity e power minus s t into 0 to infinity e power minus t say x square dx and whole into dt. Now, without losing the property, we can interchange the order of this integration, that is, now it is having your dx. With respect to dx, I have to integrate first, and then with respect to t, I can change this order. So, that first I can integrate with respect to t, and then we can integrate with respect to x. So, if I write down that thing, then 0 to infinity, here it will come 0 to infinity e power minus s t into e power minus t x square dt into dx. This is equals 0 to infinity, what is happening? E power, what I can write down? E power minus s t into f t dt form again. This integral, if you see, this is in the form of 0 to infinity e power minus s t into f t dt, where f t is nothing but e power minus t x square, and which is the definition of the Laplace transform. So, that this I can write down Laplace transform of e power minus t x square into dx, Laplace transform of e power minus t x square into dx. I know what is the Laplace transform of e power minus t x square. I know this thing, Laplace transform of e power a t. What is this? If you recall, this is equals 1 by s minus a. Laplace transform of e power a t is 1 by s minus a. So, that this I can write down as 0 to infinity dx by s plus x square. Here your a is x square minus x square. So, I can write it dx by s plus x square, and I know the integration of this. This is 1 by root s tan inverse x by root s, x square plus a square form, dx by x square plus s square, where a is root s. So, the value of this integral directly I can write down as this is equals 1 by root s tan inverse x by root s, where x varies from 0 to infinity. So, once I am getting this, x varies from 0 to infinity, and if I put the limiting values, ultimately I will obtain the value of this as pi by 2 root s. So, effectively what you see, what we are getting, that the Laplace transform of f t equals pi by 2 root s. This we are getting, this is nothing but the Laplace transform of f t, this we obtained earlier. So, Laplace transform of f t equals pi by 2 root s. So, once I got it, so from here I can write down your f t will be nothing but Laplace inverse of pi by 2 root s. Directly I can write down. So, that it is pi by 2 into Laplace inverse of 1 by root s, and I know what is the value of this 1 by root s, that is pi by 2 into inverse Laplace transform of 1 by root s is 1 by root pi by 1 by root pi into t. So, that this pi will be there, the value you will obtain half into pi by t to the power half. 1 pi will be cancelled, basically root pi by root t. So, f t you are getting half into pi by t to the power half. So, you see, using the convolution, using the properties of Laplace, I am obtaining the value of your f t. So, that you can now tell that your 0 f t is what? F t is 0 to infinity e power minus t x square dx. This is equals half into pi by t to the power half. And what you have to evaluate? You have to evaluate 0 to infinity e power minus x square dx. So, that if I put t equals 1, then from here I will obtain 0 to infinity e power minus x square dx. This is equals to root pi by 2. Therefore, the value of this one at t equals 1, it is 0 to infinity e power minus x square dx, which is equals to root pi by 2. So, like this way, if I want, I can evaluate the integrals also using the concept of Laplace transform. Only thing you have to remember that I am constructing a new function, and from that new function I am taking the Laplace transform, and I am finding the value of that function. Like I constructed the new function f t as 0 to infinity e power minus t x square dx, and afterwards by substituting t equals 1, I am obtaining the value of the original integral, that is 0 to infinity e power minus x square dx equals root pi by 2. Let us see the one more example. So, I want to evaluate 0 to infinity cos of x square dx. 0 to infinity cos of x square dx. So, like earlier cases, I have to take a new parameter t. So, obviously, I will take cos of t x square dx. I am taking a new function f t, which is equal 0 to infinity cos of t x square dx. So, that afterwards, if I substitute t equals 1, I will get back the original integral, that is cos of x square dx. Now, take Laplace transform on both sides of the given equation. So, Laplace transform of f t equals this one, Laplace transform of this quantity, this I am not writing this. So, if I evaluate, I will obtain 0 to infinity e power minus s t into f t dt. Like the earlier case, 0 to infinity e power minus s t into f t is again this integral 0 to infinity cos of t x square dx. So, I am writing 0 to infinity cos of t x square dx into dt. So, now I can change the order of the integration, that is I can integrate dt first and then dx first without losing the properties. So, that this equals I can write down 0 to infinity e power minus s t into cos of t x square dt into dx. Again you see cos of this, what is this integral again? This integral again is nothing but the Laplace transform of cos of t x square from the definition. A Laplace transform of cos of t x square is 0 to infinity e power minus s t into cos of t x square dt. So, that you can write it as 0 to infinity Laplace transform of cos of t x square into dx. And Laplace transform of cos of t x square dx, that is equals to 1 by s square plus x to the power 4. So, that I can obtain s will go over here s square plus here a is x square. So, this will become x to the power 4 into dx. So, your integral becomes Laplace transform of f t equals 0 to infinity s by s square plus x to the power 4 into dx. I have to evaluate now this integral. Let us substitute this thing, x square equals say s tan theta. I am just substituting x square equals s tan theta, that is x equals root s into tan theta. So, on this I am using this one, x square equals s tan theta, that is x equals root s into tan theta. So, that you can find out your dx from here. From here you can find out the dx. Your dx will be s sec square theta by this will be 2 into root over s tan theta into d theta. Your dx will be this thing, dx will be equals to x s sec square theta by 2 into root over s tan square s tan theta d theta. So, now dx is this, you have assumed x square as s tan theta. Effectively, I am doing this so that I can obtain a very simpler form, which for which I can obtain the solution. So, using this, your next step is then Laplace transform of f t. This is equals 1 by 2 root s from the earlier one. I can write down, your limit will be changed to 0 to pi by 2 d theta by root over tan theta, d theta by root over tan theta. So, this is again an trigonometric equation. So, please note that whenever I have to evaluate the Laplace transform, I have to remember the integration properties very well, because in each and every step I have to evaluate the integrals. So, before studying this particular topics, transform techniques, it is better if you always brush up the integration properties and how to solve the integrals. That will help you in solving the problems and to obtain the various solutions. So, this equals, you can write down 1 by 2 root s 0 to pi by 2. So, cos will be this one. So, that sin to the power minus 1 by 2 into cos to the power, this will be plus cos to the power 1 by 2 into d theta, and this is basically sin m into sine cos n cos theta, sine minus theta by 2 and this thing. So, this will be sine theta cos theta and this value I can obtain easily, that is one case will be gamma 1 by 4 into gamma 3 by 4 divided by 2 gamma 1 divided by 2 gamma 1. So, I am not telling how I am getting the required result, but you can see it, that is the reason I told I should brush up my integral processes, how to solve the solutions. So, this equals I am getting this again gamma 3 by 4, this I can write it as 1 by 2 root s into this is gamma of 1 by 4, gamma 3 by 4 I can write down 1 minus 1 by 4, gamma 1 will not be there. So, only 2 will be there. And this equals I can write down 1 by 4 root s into pi by sin pi by 4, pi by sin pi by 4, because we know that gamma n into gamma m into gamma 1 minus m, if I take this is equals to pi by sin m pi. So, I know these things, n lies between m lies between 0 to 1. So, if I do these things and if I substitute the value of sin pi by 4, then I will obtain pi by 2 into root over 2 s. So, you are getting what? Laplace transform of f t, this is equals to pi by 2 root s. So, that f t will be Laplace inverse of pi by 2 into root over 2 s. So, next let us write down that thing, f t equals pi by 2 root 2, this will come outside, Laplace inverse of 1 by root s. And once I am getting this Laplace inverse of root s, I know what is the value corresponding to this Laplace inverse of 1 by pi root s is root over t minus 1 by gamma half. So, once I am writing this, the Laplace inverse of 1 by root s is root over t minus 1 into gamma half, and gamma half is nothing but. So, this I can write down pi by 2 root 2 into, ultimately it will become 1 by root over pi into t. So, that once I am getting this value, this is nothing but half into root over pi by 2 t, I can write down, 1 pi will be cancelled. So, that pi by root t. So, Laplace inverse of this one, actually this will be not this, this will be root over t to the power minus 1 actually. So, that it will become 1 by root pi t. So, once I am obtaining f t equals this, now put t equals 1 over here. Once I am putting t equals 1, then my integral will become, instead of cos of t x square, it will become cos of x square dx, and this is equals half into root over pi by 2. So, at t equals 1, I am getting the value of my original integral 0 to infinity cos of x square dx. This is equals half into root over pi by 2. So, by this way, I can evaluate the value of some integrals also using the concept of Laplace transform, convolution theorem, and I can use other properties of Laplace transform. Okay, thank you.